Understanding particle accelerators is crucial before we get into the news. The world's largest and most potent particle accelerator, the Large Hadron Collider, LHC, is a 17-meter ring of superconducting magnets run by CERN. It is the pinnacle of human scientific achievement. In fact, it is so potent that it can recreate the conditions under which the universe was born. But could this device, which is meant to reveal the secrets of the universe, also hold the key to something much more sinister? One of the most prominent research institutions in the world, CERN was established in 1954 and now has 23 member governments and thousands of scientists. It serves as a center for innovation and cooperation. Although the LHC is CERN's flagship project, it is just a small portion of an extensive network of experiments and accelerators. Imagine a racetrack for subatomic particles competing against time and space itself, instead of vehicles or horses. Thousands of magnets guide the protons on their journey, while complex cooling systems keep the magnets at temperatures lower than outer space. The beams inside the LHC are designed to collide at 4 locations around the accelerator ring, which correspond to the positions of 4 particle detectors. The LHC accelerates protons to almost the speed of light, sending them on a collision course that mimics the energy of the universe at the time of the Big Bang. CMS Atlas together, ALICE and LHCb behave as enormous cameras, taking pictures of these collisions while each has a distinct function in investigating various facets of particle physics. After that, researchers search through the debris for indications of other events that provide clues to the basic building elements of the cosmos, include the mysterious Higgs boson, often referred to as the God particle. We may learn more about the macrocosm by examining the microcosm, yet every solution raises a new query, and every discovery a fresh obstacle. The LHC is more than just a scientific tool. It is a symbol of human ingenuity and curiosity. It represents our unwavering quest for knowledge and our desire to comprehend the fundamental forces that form our universe. But as we push the limits of what we currently know, we also need to think about the existential and ethical issues that come up. What are the risks of exploring the unknown? Could our search for knowledge unintentionally reveal forces beyond our control in the sacred halls of CERN, where the limits of human understanding are continuously pushed? A new discovery has surfaced that makes even the most seasoned scientists shudder. Former CERN researcher Brian Cox, a respected voice in particle physics, recently made a revelation that has both captivated and alarmed people worldwide. Cox's remarks have an eerie clarity. CERN's Large Hadron Collider aims to replicate a miniature Big Bang. Yes, you read correctly, a microscopic replica of the event that created our universe. The physicist continued by outlining the ramifications of this objective and stressing the LHC's remarkable capacity for new discoveries. This involves its capacity to discover the mysteries of the Higgs boson and imagine having the capacity to conjure the very essence of the universe and have the power of creation in your hands. Dark matter is a mystery material that makes up a major chunk of the cosmos. This is an exciting but dangerous prospect. The LHC's temperatures, pressures, and raw energy all replicate the circumstances of the universe's early stages, making the tiny Big Bang more than just a theoretical idea. When working on the U-70 synchrotron at the Institute for High-Energy Physics in Pino, Russia, in 1978, a malfunction caused the Russian physicist Anat Borsky's head to inadvertently come into direct contact with a proton beam. The beam then passed through his skull with an unfathomable force, entering the back of his head and exiting through his nose. It's like standing at the beginning of time, witnessing the birth of existence itself, but with such power comes responsibility, and the question looms: what if something goes horribly wrong? Borsky had an unearthly experience when he witnessed a flash that was as brilliant as 1,000 suns, yet he was pain-free. He stayed awake and even went to the clinic for treatment despite the beam's route leaving a trail of destruction that burned through bone and tissue. The aftermath was both terrifying and interesting. The incident is not only a personal tragedy but also a warning that highlights the enormous power and potential danger of particle accelerators. The risks of a particle accelerator like the LHC are not to be taken lightly, as there is a chance for unexpected reactions. The beam's path caused localized tissue death, which resulted in hearing loss in one ear and partial facial paralysis, but remarkably, Borsky's intellectual abilities remained intact and he continued his scientific career. Some members of the scientific community have expressed genuine worries about the manipulation of space and time, which is not the subject of science fiction. The potential for producing a small black hole is among the most fascinating and concerning issues related to the LHC's research. Though CERN scientists have assured that any black hole created would be unstable and evaporate almost instantly, the mere possibility has sparked debates, fears, and awe at the power we wield. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, and mysterious entities that lurk in the shadows of our universe. The idea that the LHC could create such an entity, even on a microscopic scale, is shocking to both the general public and experts. It has to do with the basic mechanics of particle accelerators. When protons collide at almost the speed of light, so much energy is released that it distorts spacetime itself. Picture a tautly stretched trampoline, and then a heavy weight is dropped onto it. The fabric bends and curves, and if the weight is heavy enough, it could create a depression so deep that anything nearby would be drawn into it. This is a simplistic metaphor for what could happen in the LHC. In the realm of quantum physics, where the laws of the universe are both strange and beautiful, there is a theory that extra dimensions may be concealed within our reality. If these dimensions exist, the collisions of the LHC could tap into them, creating a gravitational funnel that forms a microscopic black hole. Some well-known scientists have even taken notice of this mysterious particle dance, most notably the late Stephen Hawking, who in his book forewarned of a situation in which the Higgs boson may become unstable at very high energy levels, which in turn could result in a catastrophic vacuum. Decay is a cosmic occurrence that would wipe out the whole cosmos in addition to Earth. In his book on the future possibilities for humanity, renowned British cosmologist and astronomer Sir Martin Rees also voiced his worries over the CERN experiments. He examined the possible dangers connected to particle accelerator operations, including those at CERN. He described a worst-case scenario in which a botched experiment could produce a state known as vacuum instability, which could theoretically cause a phase transition that would ripple through the very fabric of spacetime and result in a cosmic catastrophe that could engulf the entire universe. His words were not just warnings, they were tinged with existential dread. Rees's worries went beyond just theoretical reflections. He gave these disastrous consequences a possibility, although a little one, and contended that even that small chance should cause us to stop. The margin of error is razor narrow, and the stakes are unthinkably enormous. The scientists at CERN have calculated the probabilities, run the simulations, and examined the theories to argue for the safety of the LHC. In fact, Brian Cox himself acknowledged the importance of responsible exploration, recognizing that there are widespread fears and concerns surrounding the activities of the LHC. He emphasized that there are rigorous safety measures in place, extensive reviews and protocols that ensure the LHC's operations are conducted with the utmost care. Cox reassured that the energies involved are well within what the Earth naturally encounters, and the chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so tiny and so unstable that it would evaporate in a flash of energy, a phenomenon predicted by Stephen Hawking known as Hawking radiation. It would be a fleeting moment of cosmic wonder, a glimpse into the abyss, and then gone. Some have gone further, speculating that the LHC's experiments could open a portal to another universe or dimension. This notion, though largely dismissed by the scientific community, has captured the imagination of many and has become a subject of fascination, fear, and even folklore. What lies beyond our reality? Could we inadvertently unleash forces or entities that we do not understand? How did this notion originate? And what does it represent in the context of scientific investigation? The concept of creating a door to hell has even been sensationalized in the media, adding fuel to the fire of confusion. In physics, the idea of parallel dimensions is not new. Consider the LHC as a cosmic key that unlocks doors that have been sealed since the beginning of time, when protons collide at energies never before achieved on Earth. This could potentially tap into these hidden realms. String theory, a leading candidate for a unified theory of everything, suggests that there may be more dimensions to space than the familiar three. These additional dimensions may be compactified or hidden from our perception, but they could theoretically be accessed or revealed under extreme conditions. In summary, the CERN has many ramifications, but like every scientific frontier, there are dangers and benefits. With each new discovery, the Large Hadron Collider serves as a reminder of the enormous hazards associated with venturing into the unknown while simultaneously serving as a monument to the brilliance and ambition of humanity in their quest for knowledge. The issue of whether we are really ready for the power we are releasing continues as we go closer to the edge of a huge uncharted universe where the lines between existence itself, science, and ethics are blurred.